Alrighty, on with the next one. As per request, we are doing another limiting reactant problem. I'm making this one up, so we'll see how it goes. It's going to be with acids and bases this time, because that is what the limiting reactant problem will be on our next test. I actually just figured that out. Thank you, Miss Burnett, for letting me know. Let's get on with it. So we've got potassium hydroxide plus a little hydrochloric acid, which gives us potassium chloride and water as a result. So let's say we have 25, that's a horrible 2, 25 grams of potassium hydroxide. And then we have a point, we'll say a 0.5 molarity solution. And what sounds like a good number? We'll do, I feel like 50 milliliters, yeah. But first, let's, 1, 2, we'll do 3 sig figs for this. So 50.0 milliliters, molarity. So that means you, sir, need to be changed to 0.0 grams. All right, so we're going to figure out which one runs out first, just like we did with the other one, and how much of the leftover one we'll have. And let's do something a little different. Let's find out how much water we're going to produce from this. So how much water will be produced? Well, yeah, let's just do moles. How many moles of water will be produced from this? A little disclaimer. Most likely on the test it will be how many grams of a certain substance are produced and not how many moles, but I do cover both of those options later on in the video, so we're good for that. Yeah, that's good. So first, to start off, we need to find the molar mass of potassium hydroxide, which, if we pull up our trusty little PubChem over here, or just your periodic table that you were using before, what were we looking for? Periodic table right there. And we're looking for, oh wait, no, not the periodic table. We're looking for potassium chloride. So KOH, not potassium chloride, that's the other one. Potassium hydroxide. There it is. 56.1, we'll say 0.11. 56.11 grams per mole. So then our hydrochloric acid, we don't quite need to know that, because if we write our formulas over to the side, we remember that molarity is equal to the amount of moles, over the amount of liters. And remember, I'm going to get it right this time, milliliters to liters is dividing by 1,000, and liters to milliliters is multiplying by 1,000. So for this, if we take our 0.5 0.5, that's a terrible 5, 0.5 molarity solution equals our moles over our liters, which would be, let's pull up the calculator, I think it'll be 50 divided by 1,000. Should be 0.05. 0.05. And then multiply the two together, multiplied by 0.5. We get moles equals, how much was it? 0.025. And there's 1, 2, 3. Oh, no. Ones in front don't count. Always forget that, so we'll put another one at the end there. But we'll just pretend that's there. So, that is how many moles are in this. Now let's find out how many moles are in this at 25 grams divided by our grams per mole, because going grams to mole, you divide, moles to grams, you multiply. So 25 divided by 56 .11 equals point. So our red one will be, is that 0.4 repeating? 0.446. 0.446. So I'll actually write this one up here. 0.446 moles. Now, you might notice that one of these numbers is quite a lot bigger than the other, which means we are going to go off of this one. Since it's smaller, it will be the limiting reactant. And since these are all 1 to 1 to 1 to 1, this can also answer the question of how many moles of water are going to be produced. It will be 0.025 moles, since these are all the same, and we're using this amount since it's our limiting reactant. So that's a pretty easy question to answer. So why not answer how many moles of that and how much of this is going to be produced? How much of this is going to be produced? We'll do that a little bit later, once we figure out how much of... Actually, no, let's do that first. How much of this is going to be left over? So, since it's all 1, 1, 1, 1, that means what color should you use? You'll be purple. So you are going to be 0.025. That's a little large. 0.025 moles at... Nope, not that one. Where is it? There it is. It is potassium chloride, so Cl. Obviously, you'll have your periodic table to do all this. I don't have mine with me at the moment, so this is just how I'm doing it. Again, for studying, PubChem is a wonderful website. It's a bunch of stuff. 74.55. So you are 74.55 grams per mole. So that means that's the amount of moles we have. And remember, to get from moles to grams, you multiply. So 0.025 multiplied by 74.55 is, hold on, times 74.55 equals 1.86 grams. That's our answer for that. And then our answer for the water is going to be the same as this over here. So it'll be 0.025 moles. There's both of our product answers. Now, if we go back over here to the side, how many grams will be left over from this? Since we used 0.025 moles, again, 1-to-1 ratio, so however many we use of this, we'll be using this. So what we can do is figure out how much that is. Again, since we have moles, 0.025 multiplied by this number, 56.11 equals, so 0.025 times 56.11 equals, what was that, 1.4? 1.40 grams of the stuff used. Now to find how much is left over, we simply subtract the two, so 25.0 minus 1.40 equals, I want to say 23.6, but I'm not sure. 25 minus 1.4, yes, 23.6, I was right, okay. 23.6 grams left over. Those are your three answers right there. Now, this problem incorporates stuff we did from previous units with our, what's it called? Limiting reactants, and finding how much is left over and finding out which one is the limiting reactant. And in case you missed it, in this case, it would be the HCl, or hydrochloric acid, in this case, which is the limiting reactant. And then it also includes stuff from this unit, which was over solution stoichiometry, which, if you've got this down, you're going to nail the math on the test. So, happy studying. Good luck. Hope you get that extra credit. Goodbye.